Okay, this is lesson 6.3, converting rates and measurements. So we can use dimensional analysis to convert measurements into different units. Dimensional analysis involves using units of measurement as factors when you compute. This helps you keep track of the units of measurement and also ensures that you are performing the correct operations. Sometimes we just get a little confused about whether you should multiply something by 12 or divide by 12 if you're changing from feet to inches versus inches to feet. And it gets even more confusing when you have something that has multiple units in it, like a rate. Sometimes it's hard to tell which way you're going with some of those conversions. So dimensional analysis will help you keep track of that. So let's see what that looks like. Example 1 says the average teenager spends $1,742 per year on fashion-related items. How much is this per week? Okay, so the way dimensional analysis works is you'll write your thing that you're changing. This is a rate, $1,742 per year. You'll write that as a fraction, so $1,742, and then it says per year, so that's per 1 year. And if we look at what we're trying to change, this is year, and we're trying to change it to week. So the conversion that I know is that 1 year is equal to 52 weeks. So what I'm going to do is multiply this rate by something that's equivalent to 1. If these two things are equal, I can put 1 year in the numerator of this fraction and 52 weeks in the denominator. Because these are equal, this whole thing is equivalent to 1. Now the point of this, if you look at this, if you look at your units, years on the top and years on the bottom will cancel. Just like you would cancel factors when you're multiplying fractions, you can cancel units here. So now if you see what we're going to be left with, we have dollars and we have weeks, and that's what we wanted. How many dollars is this per week? So then we'll go ahead and divide this. We see that we have $1,742 divided by 52 weeks. And when we divide this, this comes out to $33.50 per week. And this again helps us to know for sure that we've put the correct numbers in the right place because we can see the years cancel, one on the top and one on the bottom. Alright, let's look at example 2. Example 2 says a swimming pool is being filled with water at about 300 gallons per hour. How many quarts per second is this? Now our original units were in gallons per hour. So not only are we changing gallons to quarts, but we're also needing to change hours to seconds. So we're going to have multiple conversions that need to be done in this problem. So let's start off the same way we did with the first one. Let's write our original rate as a fraction. So we have 300 gallons per 1 hour. And conversions, it doesn't matter here if you want to go from gallons to quarts first, or if you want to go from hours to seconds first. You're going to have to do both of them eventually, so just pick one and go with that first. So let's change the gallons. I know that 1 gallon is equal to 4 quarts. So when I multiply here, again, remember we want the gallons to cancel, so I want the 1 gallon to go in the denominator and the 4 quarts in the numerator. So now I can see gallons cancels with gallons. Okay, so now I have quarts per hour, but I still want quarts per second. So now let's use another conversion. I know that 1 hour is equal to 60 minutes. So I'm going to multiply this by, let's see, hours in the denominators, so I need hours in the numerator. So 1 hour, 60 minutes. Hour cancels with hour. And now we have quarts and minutes. But again, we still want quarts per second. So one more conversion. I now know that 1 minute is equal to 60 seconds. So we want the minutes to cancel. Minutes is in the denominator, so I need minutes in the numerator. 1 minute, 60 seconds. Minutes cancels with minutes. Now look at our units. We're right where we wanted to be. Quarts over seconds. So we'll go ahead and multiply straight across the top. We have 300 times 4, and our units are quarts. So that's 1,200 quarts. And in the denominator, we have 60 times 60, and our units are seconds. So that's 3,600 seconds. And if we go ahead and divide this, this is approximately 0.33 quarts per second. Okay. Now, sometimes it's necessary to convert measurements between the customary and metric systems. Customary system is things like inches, feet, yards, miles, and then gallons, quarts, just the units that we typically measure things in. The metric system is everything that's in those powers of 10. So millimeters, centimeters, meters, kilometers, liters, milliliters, and so on. Kilograms, grams, all of those. So there's a table with conversion factors that on page 276 in your textbook. Most of these conversion factors you're probably not familiar with, so you may want to bookmark this page so that you can refer to it easily to be able to do your conversions. Now, if you look at that table, it will show you one conversion on one side of the page and another one on the other side. So either conversion will work. It may show you that 1 foot is equivalent to some number of meters, but then it may also tell you on the other side that 1 meter is equivalent to some number of feet. It does not matter which conversion you use from that table. Just use one that's equivalent that will change your units to what you want them to be. Alright, so let's look at example 3. It says complete each conversion, round to the nearest hundredth. So for part A, we want to change 4 pounds to kilograms. So here we don't have a rate, we just have one single amount. It's just 4 pounds. But we'll still use dimensional analysis to keep track of our units when we change this. So if you look at the table on page 276, one of the conversions you see is that 1 pound is equal to, or approximately equal to, 0.454 kilograms. So when I multiply this by some fraction that's equivalent to 1, here I have pounds in the numerator, so I need pounds in the denominator. So 1 pound will go in the denominator, and 0.454 kilograms will go in the numerator. And just like we want to have happen, the pounds will cancel. We're left with an answer that will just be in kilograms. So now all we have to do is multiply. 4 times 0.454. And it says to round to the nearest hundredth. So this comes out to 1.816. So we will round, since the 6 is bigger than 5, we will round that up to 1.82 kilograms. Okay, part B is similar. It says to convert 15 meters to feet. So again, we'll start off with our original value. Our original amount is 15 meters, and we want to change this now to feet. Well, a conversion that you can find on page 276 says that 1 meter is approximately 3.279 feet. So we'll multiply this by, again, a fraction equivalent to 1, and the meters here are in the numerator, so we need meters in the denominator. So 1 meter, and then in the numerator, 3.279 feet. And just like we like to see happen, meters and meters will cancel, 1 in the numerator, 1 in the denominator. So now all we need to do is multiply here. 15 times 3.279, and again, round to the nearest hundredth. It's comes out to 49.19 feet. Okay, let's try one more example. This says a cyclist is cycling about 3 kilometers per hour. Rounded to the nearest hundredth, how many feet per second is this? So again, look at the units in the problem. We're given kilometers per hour, and we want to know the equivalent amount of feet per second. All right, let's write down our original rate. So this is 3 kilometers per hour, so per 1 hour. And remember, it doesn't matter if you want to do the kilometers to feet first or if you want to do hours to seconds first. Either way will give you the same result. So I like to start with the whatever's in the numerator. So let's change the kilometers first. So if you look again at the table on page 276, you'll see that you have a conversion that goes from kilometers to miles. So we'll have to go to that first and then change from miles to feet. So that conversion says that 1 kilometer is approximately equal to 0.621 miles. So when we multiply kilometers in the numerator, so we'll put kilometers in the denominator. 1 kilometer, 0.621 miles. And now our kilometers will cancel. We have units in miles now. We still want to get to feet though, not miles. So let's go ahead and get another conversion. We know that 1 mile is equal to 5,280 feet. So to cancel the miles in the numerator, we need miles in the denominator. So this is 1 mile and 5,280 feet. Miles cancels with miles, and we're left with units in feet, which is what we wanted. Except we still have feet per hour, and we want feet per second. So we still need to change hours to seconds. So another conversion to go from hours to seconds. Well, we can go from hours to minutes by using that 1 hour is equal to 60 minutes. So hours in the numerator, or in the denominator, so we need hours in the numerator. We'll put 60 minutes in the denominator. Hours and hours cancel. And our last conversion, now we need to go from minutes to seconds. So we know that 1 minute is equal to 60 seconds. So to cancel the minutes in the denominator, we'll put minutes in the numerator, 60 seconds in the denominator. Minutes and minutes cancel, and double check. We have feet in the numerator, seconds in the denominator. Feet per second. So now, if we multiply straight across the top, 3 times 0.621 times 5,280, and our units are in feet, and that comes out to 9,836.64 feet. And then multiply straight across the bottom. So we have 60 times 60, and our units are in seconds. So that's 3,600 seconds. And then to actually give it as a unit rate, how many feet per second, we'll go ahead and divide these so that we get a denominator of 1. And 9836.64 divided by 3,600 is approximately equal to 2.73 feet per second.